Hello students, welcome back. Students, today we will first discuss some questions which are based on calculation of significant figures, and then we will move on to the next topic, that is dimensional analysis, and after that we will discuss laws of chemical combination. So students, here I have some questions. Now in first question, so statement is in the final answer of the expression. Now expression is 29.2 minus 20.2 multiplied by 1.79 into 10 raised to the power 5 divided by 1.37. The number of significant figures is. Now, so students, you have to find out the number of significant figures in the final answer of this expression. Students, this question was asked in AIPMT 2004. Now students, to solve or to find out answer of such questions, the calculations as such are not required. Now students, see, we know that first 29.2 minus 20.2, so this will be what? 9.0. So how many significant figures we have when we subtract 29.2 and 20.2? We have 9, which has two significant figures. So this calculation, that is 29, has two significant figures. Now when we multiply this with a number which is in scientific notation, the coefficient has how many significant figures? Because significant figures are given by the coefficient part, that is 3 significant figures. Now students, in multiplication, that is when we multiply 9 with this 1.79, we know that in multiplication the answer should be reported up to minimum number of significant figures. So that means our answer should be reported up to 2 significant figures. Now इसका मतलब ये हुआ that this into this will have a result in how many significant figures? 2. And now students, see, we are dividing again this by 1.37, and this has how many significant figures? Again 3 significant figures we have. But students, now in division we know that when we divide two terms, then the final answer should be reported up to the same number of significant figures as are in the number or term with minimum significant figures. So again here also we have how many significant figures? Minimum 2. So that is why students, our answer is option B. So here calculations are not required. You just see that this result has 2 significant figures, this has 3, this has 3, and we know that in multiplication and then division the final answer should be reported up to minimum number of significant figures. That means we have to give our answer in least precise term, which is having 2 significant figures, and that is why answer is option 2. Now students, there is another question. If the density of a solution is 3.12 gram per milliliter, the mass of 1.5 milliliter solution in significant figures is. Now student, density is given. Now, and we have to find out the mass of this much volume. Now students, what is density? Density is mass upon volume. So from this, mass will be density into volume. Now density is 3.12 gram per milliliter and volume is 1.5 milliliter. Now students, see here, again we are multiplying two terms. One has 3 significant figure, the other term has 2 significant figure. So obviously your answer should be reported up to how many significant figures? That is, it should be reported up to 2 significant figures. Now students, see, all these answers have, this has 4 significant figures, again this has 4 significant figure, this has 4 significant figure, but our answer should be in what? So let me first, अगर आप calculate भी करते हैं, upon calculations you will get 4.680 gram. But students, this number has 4 significant figures, but our answer should be reported up to 2 significant figures, as this term has 2 only. So 2 significant figures means we need this much only. So that means we have to round off now. When we eliminate 8, which is more than 5, we retain this digit with an increment of 1. So this becomes 4.7. So our answer is option A. So this question is from NCERT exemplar book. Now students, we have third question. Now 3 successive measurements in an experiment gave the values. So first value is 10.9, then second is 11.4042, and then we have 11.42. Now the correct way of reporting the average value is, now students see, first we'll take average of these. So 10.9 plus 11.4042 plus 11.42, and we divide it by 3. But students, now see, this is a question where first addition is carried out, and we know that in addition final answer should be reported up to what? Minimum decimal places, which are in this term, that is 10.9. And since this is the exact number, this has infinite number of significant figures, so we consider only these terms, and here we have 10.9 as the least precise term, so our answer should be up to 1 decimal place, and therefore students, the average when reported up to what? Minimum number of decimal places will be 11.2, because we need to report this answer up to 1 decimal place only, and only this has what? 1 decimal place, or we say this has only 3 significant figures. And students, this question was asked in KVPY exam 2014. Now we have another question, student. This question was asked in IIT JEE exam 2010. Now student, the question is, a student performs a titration with different B rates and finds the titer value of 25.2 milliliters, 25.25 and 25 milliliter. The number of significant figures in the average titer value is. So again we find average, and students, again see, we have this term with 3 significant figure, we have this with 3 significant figure, we have this with 3 significant figure, and since this term has minimum number of significant figures, that is 3, our final answer should be reported up to same number of significant figures, means 3. So it may be 3 here. So our final answer should be reported up to 3 significant figures. So students, you must have observed that in all these questions, the calculations as such are not required. You just have to find out the answer on the basis of rules which we have discussed. Now students, our next topic is dimensional analysis. Students, so next topic is dimensional analysis. So students, what is dimensional analysis? So expressing a physical quantity in terms of fundamental quantities is called dimensional analysis. So in dimensional analysis, we express a physical quantity into or in terms of what? In terms of fundamental units, you may say. So the basic objective of dimensional analysis is to convert a physical quantity given in 1 units into some another unit system. So students, what is dimensional analysis? समझ आ गया? इसमें हम क्या करते हैं, एक फिजिकल क्वांटिटी को एक्सप्रेस करेंगे इन टर्म्स ऑफ फंडामेंटल यूनिट्स, और मेन ऑब्जेक्टिव जो डायमेंशनल एनालिसिस का है कि हमारे पास कोई भी फिजिकल क्वांटिटी है, हम उसको एक गिवन यूनिट सिस्टम से किसी दूसरे यूनिट सिस्टम में कन्वर्ट कर सकते हैं. एंड स्टूडेंट्स, फॉर दैट वी रिक्वायर सर्टन unit factors, or we say we require a method known as factor, which is called factor factor level method or unit factor method. And the basic requirement is that that the quantity or the unit required is equal to the quantity given into it is CF. Now this CF is the unit factor. Generally we take it as 1. So this is the basic requirement. Means जो unit system आपको चाहिए वो आपका numerator में रहना चाहिए, because this common factor will be now what the quantity required. So जो आपको unit system जिस को चाहिए या desired है वो ऊपर रहना चाहिए, that means numerator में, and then the quantity given. So this is the basic idea of dimensional analysis. Now students, आपको समझाने के लिए मैं एक एग्जाम्पल देता हूं और rather एक क्वेश्चन की फॉर्म में उसको हम समझ लेते हैं. Say the question is convert say 3 kilometers into inches. Means how many inches are there in 3 kilometers? And students, it is given that 1 kilometer is 1000 meter and 1 meter is these many, that is 1.094 yards, and 1 yard is 36 inches. So this is the information which is given, and now using this data we'll find out how many inches are there in 3 kilometer. So student, 3 kilometer can be written as 3 kilometer into. Now we need here how many unit factors? Students, we need 3. First we'll convert kilometers into meters. So for that we use first unit factor, say CF. Then meter will be converted into yards. For that we use or we need second unit factor, and then yard will be converted into inches, so we need third unit factor, so it is called common factor also. So yeah. Now students, so we have 3 kilometer. Now what will be first unit factor? See, first unit factor will be, we require first meters, so using this we can write unit factor 1000 meter, because this is what we require, upon 1 kilometer. So see, now this is 1000 meter upon 1 kilometer, and देखो इससे ये cancel हो गया. So now we have answer in meters. Now but we require in inches. So but meter से inch में सीधा नहीं जाओगे आप. First we have a conversion. So we will now use another common factor or unit factor, and we require what now? Yards. So we'll have this yards upon what? 1 meter. So we have now 1.094 yards upon 1 meter, and this will result in cancellation of meter system. But still we have not reached to this point, that means inches mein answer nahi aaya. So we need now the third factor, now which is 36 inches upon 1 yard, so that yard they cancel out. So we have 36 inches upon 1 yard. Now yard and yard they cancel out. So finally see now students, we have 3 into 1000 into 1.094 into 36, and now see our answer is in what? Inches. Student, this is how we use dimensional analysis to convert a physical quantity given in one unit system into another unit system. Now students, similarly you can apply this fundamental to express any physical quantity. It can be volume, it can be density, but for that you must have the data, like you should know these relations also. Similarly for volume, the students, you must know that what is the relationship between volume in meter cube to centimeter cube, liter, milliliter, decimeter cube, etc. Now students, will move on to the next topic, which is very very important, laws of chemical combination. Students, our next topic is now laws of chemical combination. Now students, what are laws of chemical combination? So I must tell you that in chemistry, that is in chemical sciences, the generalizations are made on the basis of certain laws, which means in chemistry all the chemical reactions, they take place according to laws, and these laws are called laws of chemical combination. So students, we have 5 laws of chemical combination. The first law is called law of conservation of mass. This law was given by Antonio Lavoisier in 1789. Then we have law of definite proportion, which was given by J.L. Proust in 1799. Third law is law of multiple proportion, which was given by John Dalton, and it was given in 1804. And then we have law of reciprocal proportion, which was given by Richter in 1792. And then lastly we have Gay-Lussac's law of combining volumes, which was given in earlier 19th century, that is 1808. Now students, will discuss first law, that is law of conservation of mass. So what is law of conservation of mass? So student, this is a very simple law. The statement of the law is that in any physical or chemical process or change, the total mass of reactants is equal to the total mass of products. Say for example, if I have A plus B reactants and they form products C and D, then according to this law, the total mass of reactants, that is mass of A plus mass of B. Now total mass of reactants is equal to the total mass of products. So it is equal to mass of C plus mass of D. So if this is a hypothetical chemical equation, then we say the total mass of these two reactants must be equal to the total mass of these two products. Now students, this means that matter can neither be created nor destroyed, or simply we say mass remains conserved. That is why we call this as law of conservation of mass. Now students, there is limitation also. Now this law is applicable for all chemical reactions, but students, this law does not apply to nuclear reactions. This law does not apply to nuclear reactions because students, you must have learned in say class 10 also that in nuclear reactions there is some mass defect. That means during nuclear reaction a certain mass is converted into what? Energy, which means energy may remain conserved in nuclear reaction but not mass. So we have one limitation, that this law does not apply to what? Nuclear reactions. So this law is not applicable to nuclear reactions because nuclear reactions involve a mass defect, which means when say nuclear disintegration takes place, the total mass of products and reactants will be different. There will be difference in the mass, and that difference in mass actually gets converted into energy. And students, since we have an energy mass equivalence which says E is equal to mc square, that means say if in a chemical reaction Mass is conserved since C is a constant, so that means E is also conserved. So students, this law of conservation of mass can also be called as law of conservation of energy. Why? Because there is an energy mass equivalence which was given by Einstein. Now students, let us apply this to some questions. So I'll give you one question. A very simple question, student, is. So I'm giving you one question. Now, so the question is 20.8 gram of barium chloride on reaction with 9.8 grams of sulfuric acid, that is H2SO4, produces 7.3 grams of hydrogen chloride and some amount of barium sulfate Now students, the amount of barium sulfate is, so barium sulfate in this reaction is how much? So student, this is a very simple question. Barium chloride when reacts with H2SO4, it gives barium sulfate which tends to precipitate out, and then there is HCl, now being a gas which escapes. So when we balance this, so it is already balanced. Now students, this is a chemical reaction. Now mass of barium chloride is given, it is 20.8 gram, and it reacts with what weight? 9.8 grams of sulfuric acid and produces 7.3 grams of HCl. So what is the weight of barium sulfate? Now students, apply, we know that mass remains conserved in a chemical reaction. So we say the total mass of reactants, that is 20.8 plus 9.8, this is equal to, let this be X, and we have 7.3 grams. So solving this, we get 20.8 plus 9.8 minus 7.3 grams. So students, solving this, we get 23.3 grams. So this is the answer. So this is a very simple law, and it is applicable for all chemical reactions except nuclear reactions. Now students, the next law is law of definite proportion. Law of definite proportion. This law was given by J.L. Proust. Now, what is law of definite proportion? So first, we'll discuss what is this law, definite proportion. Students, this law is also known as law of constant composition. This is also called law of constant composition. Now, students, statement of this law is that a pure chemical compound always contains same elements combining together in same proportion by weight, irrespective of its source or method of preparation. Which means, अगर मैं से हिंदी में आपको बताता हूं कि एक प्योर केमिकल कंपाउंड में जो उसके कॉन्स्टिट्यूएंट एलिमेंट्स हैं हमेशा वो एक डेफिनेट प्रोपोर्शन पे कंबाइन करेंगे, फिर चाहे उसका जो सोर्स हो या फिर उसका मेथड ऑफ प्रिपरेशन है चाहे कोई भी रहे. से मैं एक एग्जांपल के साथ लेता हूं स्टूडेंट्स. आई हैव कार्बन डाइऑक्साइड. नाउ we know that carbon dioxide can be prepared by several methods, like it can be prepared by combustion of carbon, it can be prepared by thermal decomposition of calcium carbonate which gives calcium oxide and CO2, or it can be prepared by action of acid HCl on say calcium carbonate. So we get calcium chloride plus we get water and we get say carbon dioxide. So there can be many methods for the preparation of same compounds. But look, the compound is same, and therefore in all these compounds, whether we prepare CO2 by this method, or by this, or by any other method, the elements that combine to give CO2 are same. They are carbon and oxygen. And in what proportion by weight they react? Carbon, now one carbon, say 12 gram of carbon combines with 32. So this can be simplified as what? 3:8. So that means in carbon dioxide, which is a chemical, which is a compound, the constituent elements, carbon and oxygen, combine in same proportion by weight, irrespective of the method of preparation. फिर चाहे आप उसको किसी भी मेथड से प्रिपेयर करो, वो जो बाई वेट रेशियो है बिटवीन कार्बन एंड ऑक्सीजन वो 3:8 ही आएगा. So students, this is our law of definite proportion or law of constant composition. Now students, this law has some limitations. This law has some limitations. Now, what are those limitations? We'll discuss one by one. Students, first, so these are some limitations, कुछ drawbacks हैं. First limitation is that this law is not applicable. This law is not applicable in case of what? Isotopes, which means when some of the elements they occur in say more than one isotopic forms, then this law will not be applicable. Now let me illustrate this. I have say example carbon dioxide, and we know that in carbon dioxide, carbon to oxygen, they combine in this ratio by weight. But look students, we know that carbon has isotope, radioactive isotope carbon 14 also. Say this is the CO2 that has carbon in isotopic forms, which is not 12 but C14. Then student, we have same carbon and oxygen, but the ratio in which they are combining is 12:32, or we may write it as 6:16. But look, now when we say, और further simplify नहीं हो सकता ये. So now see, the ratio in which the carbon and oxygens are combining are not same, though the compound is same. But since one of the elements say is in isotopic form, the ratio does not remain same. Students, second limitation is that in a compound, when we say elements combine in a fixed proportion, अब suppose carbon dioxide, like say मैं कहता हूँ कार्बन और ऑक्सीजन है और वो कंबाइन कर रहे हैं in this proportion, तो इसका मतलब this implies compound is what? CO2. So हम इस लॉ से ये भी कंक्लूड कर सकते हैं, if the ratio by weight between the say constituent element is same, then the compound must be same. But students, this is not always true. Let me illustrate this point that compound अलग भी हो सकता है, चाहे ratio by weight same भी हो. कैसे? I have C2H2 which is called acetylene, and then we have another compound C6H6 which is benzene. Now students, these are two different compounds, but the constituent elements in both are same, but the ratio in which they combine, here we have what? 24 gram carbon and 2 gram of hydrogen, and simplification gives 12:1. Now here see, we have carbon, 12 into 6 is 78, and then we have 6, and 72:6. We have, this is 12. Now see, the ratio by weight is same, but the compound is not same. The compound is different. So this is another limitation. Now third limitation is this law is not applicable to non-stoichiometric compounds. This is not applicable to non-stoichiometric compounds. Now what are non-stoichiometric compounds? So students, the compounds in which the ratio in which the constituent combine is not what is not actually conserved. Like when we write nickel oxide, we see one nickel is combining with one oxygen. But students, we find that nickel oxide is non-stoichiometric. It has some defect due to which the composition is a bit different. The ratio of nickel and oxygen is not 1:1, but it is 0.98:1. So obviously the weight of nickel in this compound and in this compound will be different. So students, this is our law of what? Definite proportion, and there are some limitations also. So now in next lecture, I'll tell you about the law of multiple proportion, law of reciprocal proportion, and Gay-Lussac's law of combining volumes. Thank you, students.